Okay, so calculate the volume of the following shapes. We have a cylinder here. What's the formula for the volume of a cylinder off the top of your head? Nick? Pi r squared times h. So pi times r squared times h. That's the volume of it. Okay. What is r? 3.1 millimeters, not 6.2. Okay. So that's the first thing. And then we just say, well, v equals pi times 3.1 squared times 12. Okay? And I would kind of expect you to be able to write that stuff down, put a formula down, show that you've put it in. Lots of people did, a couple of people didn't, but then there's no way of giving you marks if you don't do anything and your answer's just wrong. And the answer should be, if we work that out, 362.3, okay, or whatever you round it to. Just a little note, I generally didn't mark down, but we should be writing correct units. So if it's volume, we should have millimeters cubed, okay? So at some point, we need to be getting these correctly, because the next time, I will deduct for not putting the correct units, okay? Volume of a sphere then, again, it's like, do I really expect you to memorize the formula for the volume of a sphere? No. It's in your formula booklet, and it was. Anyone that does remember? 4/3 times pi times r cubed. This case, r is 5.6. Okay, so we just have to do 4/3 times pi times 5.6 cubed, and if we do that correctly on our calculator, we get
735.6
centimeters cubed. Okay. Volume of a cone. Volume is 1/3 times pi times r squared times h. Very simple. So we've got 1/3, which is the same as divide by 3, times pi times 15 squared times 22, and we get an answer of. Okay. Nothing other than use the formula at this stage. Some people obviously make mistakes with calculators. I can tell you why. Because you keep borrowing different calculators rather than have your own. And you don't learn how to use your own calculator properly. It adds in another level of uncertainty in an assessment. Alright, so we're going to get to a stage where I'm going to ban you from using the calculators down in those boxes. We'll keep those for M1s and M2s that don't need one at this stage. This one. Now, this one, there was extra credit, so in the overall level, I think only one person did it. There is nothing there that actually says this is a square-based pyramid. Okay? Although, if you use Pythagoras' theorem to work out that, which is half of this, you will find that the 26 squared minus the 24 squared, okay, and then square rooted gives you the answer 10. So that's 10, which means this is also 20. Okay, so that's where extra credit could have been got, but you don't necessarily need it. If you assumed it was a square-based pyramid, because that's what we've basically been doing, we then just have volume is 1/3 times the area of the base times the height. So that would be 20 times 20, 20 squared is the area of the base. The area is 20 times 20, or 20 squared, times 24. So I've got 1/3 times 400 times 24, and the answer we get is 3,200 centimetres cubed. Okay, so you could still get that answer even if you only assumed it was a square base pyramid, hence it being a level 1-2 question. Right. But if you did show that it was square based, I could give you credit where you might have lost it otherwise. All right, this one. Find the volume of the space available in the largest sphere. The largest sphere measures 40 meters in diameter. That's kind of, all this information is lovely, but it just says, I don't like that. The largest sphere is 40 meters. That's the piece of information I want. Okay. So if I were to do diagram, so here's my sphere. Don't have to do that, but it says the diameter is 40 meters. So it says find the volume. So volume is, again, same formula, 4/3 times pi times r cubed. R, this is where it's slightly more difficult than the other question, because r is 20 meters. So we have to do 4/3 times pi times 20 cubed. Okay? Which we get as 33,510.3 cubic meters, because I have to round my answer to the nearest tenth. Okay?
Would you get marked down with 100?
Yes. But in a test like this, the way we do it, there's no actual individual marks to remove. So when I go through the criteria, for instance, I wouldn't be able to give you the 7s and 8s and things, because, you know, it's more complex problems, and part of that is giving things to the appropriate degree of accuracy. So that would be a down mark in that, reaching those levels. Okay? If you do it all the time, that's it. If you do it a couple of times but the rest are fine, maybe you get away with it. Yeah? But that is part of it. If the spheres are covered in glass, find the area of the glass. So the surface area of a sphere, again in the formula booklet, is 4 pi r squared. R is still 20. So the area is 4 times pi times 20 squared. And we get the answer.
No.
Square meters. Again, if you're not getting units correct in the future, you'll lose out. Is there anyone spotting the errors and they're thinking, yeah, I really shouldn't have been getting these wrong at this stage? Yeah. Because these are still level 1-2 questions, and you know, they are just simply use the formula. There's not much to do. Now I have to admit, this question, the next question, isn't written very well. Really isn't. Okay, and it's a 3-4 question, so we kind of have to make an assumption here. Okay, which is we just go with that the volume of the pyramid is 9 centimeter cubed, a square pyramid, right? So the volume of a pyramid is 1/3 times the area times the height. Okay. We are trying to work out the area and height. So area is length times width, but they're the same value. So first step is to say, well, that's 9. Area times the height. So we can times it by 3 first to get rid of the divide by 3. And I saw some people doing this. So area times height has to be 27. And then I'm looking for a square base times something gives me 27. All right? So the answer that they came up with in the answers was, well, if the base, being a square, is 3 and 3, that makes the 9 centimeters squared. And if the height is then 3, we have 9 times 3 makes the 27. Okay? So 3 by 3 by 3 is the answer. However, you could have done other options, so let me know. Well, I think I've considered it anyway. If you worked out that the base could have been something else, so maybe the base wasn't 3 by 3, maybe you worked out it was 4 by 4, and that would be 16, and 16 times what makes 27. If you'd have worked out the height there, that could have worked. If you'd have gone with 2 by 2, so it's 4, and then 4 times what makes 27. Got these options for all. I wouldn't have been able to mark them wrong. That makes sense? Now actually, this question's not written very well because there's a part of it that I would consider, and actually they don't give you the information, but this is what they kind of intended you to do. Okay? But I took that into consideration if people got this question wrong, and the way they went about it, if it was still like a reasonable process, I still kind of considered that okay in reaching higher levels. Yeah?
One of the things that we realized after I taught it and I was looking back over it, the actual diagram shows 3 by 3 by 3 meters.
Yeah, but you're assuming, aren't you, that they are 1 centimetre pieces, but yeah, that could have given you a clue, I guess. Okay, moving on. This one, we're starting to get to a bit more kind of the challenging, the problem solving, hence it being a 5 to 6 problem. But what we try and do is do diagram, excuse me. So if we interpret what it's saying, basically we're saying that we've got a sphere in a sphere, yeah? And we've got to work out the space. So we are told that the diameter of the smaller one is 2 meters. The diameter of the larger one is 3 meters. Okay? Somebody wrote that this was 3 meters and there was another 3 meters the other side, so just misinterpreted that information. So we've got to think very carefully. So basically then what we're trying to do is always in these kind of situations, it's like doing a 2-dimensional ring, but it's in 3D. We work out the larger one and we subtract the smaller one. So large take small. But it's volumes. So we should do the volume of the larger one, which is 4/3 times pi times r cubed is 1.5 cubed. Okay? And we subtract the 4/3 times pi times 1 cubed, because that's the radius of the smaller one. Got that? And it works out as, if we do it on our calculators, This is 14.137, and we subtract 4.1888. That's just what I wrote down from my calculator. And the answer then I get is 9.9482. So I can round that to 9.95 cubic meters.
Mine's wrong. I got 9.91.
Yes, but where was the mistake in your thing? I think I spotted it.
I meant not there isn't a mistake. There isn't a.
No, what I think I did was your answer is not wrong method-wise. It's wrong rounding-wise. So I think I went through your method and didn't spot a problem with your method. So I think, did you use 3.14 instead of I don't know. I know Daniel was using 3.14.
It's because
I did subtract.
like you use 14.137 and 4.1888.
Yeah.
I use 4.19 and 14.1.
Yeah. So that's why I didn't mark it wrong. Because if you round, you can see your rounding has produced a less accurate answer, but generally, I mean, it wasn't far off, was it?
No.
If I rounded, yeah, it wouldn't be too bad. Okie doke, do you all see how that one relatively okay? If we just think about it, take it step by step. That's a very common type of problem. Take away the smaller one from the larger one. That's it. Right, next ones then. Now, we are being asked for the surface area. I even made it bold and underlined it for you. The surface area of this shape, some people were getting the right idea, just forgot something. It's basically a cylinder, isn't it?
Yep.
So we've got a cylinder
And it's a whole sphere.
plus a whole sphere. Just happens to be split in two. Right? Some of you did divide by 2 to get the one on the top and then forgot to times by 2 because you've got 2 of them. Yeah? But the cylinder is 2 pi r or pi d times h, yeah? In fact, a lot of you kind of got this bit, right? And the sphere, the surface area of the sphere is 4 pi r squared. What's r? 8. Says it there. Got it there. It's made it awkward because they didn't want to make it too easy and say it's the same as on the cylinder. Okay, they've tried to make it harder by making it go up instead of along. But you need to realise that the radius of the sphere is the same as the radius of the cylinder because it fits on top, just like in those videos we got. Okay, so we've got pi d times h, so that's pi times 16 times 10. Do you all understand that, where that comes from, yeah? You know where the pi d is? I think Daniel mentioned it in a previous lesson, wasn't it? It's the, what's pi d the formula for?
The circumference.
Of a circle. So basically what we're saying is this curved surface area of the cylinder, you kind of have to work out the height by wrapping it around the circle. So that's the circumference, and that is then the length of the rectangle. Okay? And then we've got the height. Make sense? So we work that out as, I'm going to write 160 pi just for now, and I'm going to plus 4 pi r squared, so that's 4 times pi times h squared. You can't have your own conversations. Talk to me then. Or wait till finished. Okay, so then 4 times, well, h squared is 64. Okay. So that's 256 pi. that make sense? If we work those out, we end up with an answer of 1,306.9 square centimetres. Okay? Right, any questions on that? No? This one caught most people out. Some people had a better go than others, but it really did catch people out. A lot of people had an incomplete answer. And I know it wasn't because you ran out of time, because you all handed it in early. Okay? So, what's the deal? We all noticed that it's quarter of a cylinder. So a lot of people went, okay, let's do the outside, the curved edge. So that's we'll do pi times d times height, and we divided it by 4 because it's quarter of the cylinder. Yeah, which is fine. So that's pi times d is 2 lots of 2 times 17.1, which is 34.2.
Yes.
Times the height is 20, and then you divided it by 4. And we get the answer 537.2.
I put that.
Right, but that is only the curved surface on the outside. No, so just like when we chop a sphere up, we expose other faces. What faces have we not considered?
The other four.
The other 4, right. So we also have the top, which is a quarter of a circle. And we have 2 of them. So we actually need pi r squared, which is the circle. We've got half a circle because we've got 2 quarters, so I'm going to divide that by 2. So pi r squared would be pi times 17.1 squared divided by 2, and that equals 459.32. We are still missing.
Okay.
We've got the rectangle faces 1 and 2. So we've got 2 lots of 17.1 times 20 for the rectangles. Okay? And that is 684. Making lots of noise, Michael, not writing anything down. I know you didn't get this right. So you can do one of 2 things. You can ignore the fact that ever happened to you and move on, or you can try and sort it out. Alright, so we've actually got the curved surface area. So this is the curve on the outside. This bit is the circles, top and bottom. Okay? And these are the rectangle faces. And if we add all those together, so 537.2 plus 459.32 plus 684, we get an answer of 1680.5 square centimetres. So some of you got part the way, you got the quarter of the surface area. I think a couple of you even did the circle top and bottom. I don't think anyone spotted the 2 big rectangle faces staring at them. Did you spot that? Yeah.
That's what I did first. I couldn't find areas.
Yeah. There were bits and pieces that people got together. And, you know, if we'd have put lots of answers together, we might have come together with a complete one. Does that make sense? So what was difficult about that question?
There's more steps.
Just more steps, and you have to spot all the faces.
There's a lot of shapes.
Do you know what? When I did it, when I was working out my own answers, I forgot the top and the bottom. And I went through and checked. Oh yeah, I've forgotten that. So it happens. I know the maths. The bit that I missed out on was just thoroughness, checking that I had everything, yeah? So, but because I have a better technique in exams of going through and checking that I've done everything correct, I didn't miss anything, and I spotted it. Okie doke. Final question. This question, I loved it. I thought this was really easy.
What? Well, you're a teacher.
No, Sophia thought it was easy as well. I will tell you why we found it easy. It's because we wrote it out.
I didn't find it.
Sophia, you got it right? Yeah.
We write it out like this, look. It says, let's start off with our diagram. So I have, and I'm doing it up this way because of it says about the height. So it's a cylinder with a hole through the middle, yeah? Okay?
It's a cylinder without a cylinder.
So exactly. So we're going to cut this cylinder out. All right? So there's the cylinder cut out. Okay. We are told that the volume of water that it contains is 50,000, yeah?
Yes.
All right. We are told that the height is 36. Now, you look in the picture and you have to think, well, what is the height? And a couple of you asked that. Is the height from the ground up? Because in the picture, it might be that that's the height.
It's not.
But it already tells us in another piece of information that the diameter of the base is 50 centimetres. Now, a diameter is on a circle. So that means that's the diameter.
That's the height.
Okay? So,
Yeah.
so that's what told me. So I now know that that is the 50 centimetres. Okay? It says find the radius of the hole. Now this might look at like, how am I supposed to solve this information? What do we do?
So what I did was I first calculated the volume of the whole cylinder.
Yeah.
So that way I could subtract 50,000 from the whole thing and find the volume of the inner cylinder.
Which is pi r squared.
So basically that's the principle. Now what I did to do it, I just sat and wrote it all out. So I said, well, the volume of the shape is found by doing, like that sphere one, large take away small. Yeah? So we're doing large cylinder, subtract the small cylinder. So that is pi r squared h minus pi r squared h, r being different in each case. So this r is 50. This r is the one I want to find.
How do you find the radius?
Well, what we do is we start, this is what I told you over and over and over. We put numbers in. So, volume is 50,000. This is 50 squared. Height is 36. This one got pi. I don't know r yet, but I do know that h is 36. Now I'm going to simplify it a bit, and I can say 50,000, and I'm going to work all this out as a number, and the number I get. You work?
20,000. Oh wait, of the whole thing or the inner?
Just the big cylinder, the whole thing.
Oh, 70,685.
70,685. If I subtract it, I get. I'm going to rewrite it as 36 times pi times r squared. Yeah.
You said pi 50 squared. I think it's 25 because that's diameter squared.
Good point, yeah. Well spotted. This shouldn't be 50, it should be 25. Because the radius is 25. That's why we write it all down. Okay? Now what I can do, well I know if that subtract that is this, I can then say this is equal to that subtract that. So I can say 70,685 minus the 50,000 is
20,685.
this. 36 times pi times r squared. And so what's the answer there? 20
20,685.
equals 36 times pi times r squared. Now, when we first started this topic, I gave you a question to set you all up as the topic went on. I gave you the blue hole question, yeah? And the blue hole question asked you to find what of a what?
The radius of a circle.
The radius of a cylinder, actually, because it was a deep hole. So you've done this question, so we rearrange it to find r squared. So that means I'm going to divide by the 36 and the pi. Okay, so r squared is this, and I worked that out to be 182.9. I then did the square root, and I get r is 13.5 centimetres, because that's what it is. Okay. So, it was, you'll notice how much working out, like mine, I did it while you were doing it, it's full of that, it's full of written it out, those people that got it right, full page of writing, hold it up, show us, okay, you've got to do it, you've got to lay it out, otherwise you won't be able to solve these 7 or 8 problems, but actually the maths is something you've done a lot of, okay, so congratulations those. Thomas, Michael and Hucken, I want to speak to you at the end of the lesson, please. And that's on video.